Very good evening, Harika. Actually, today's my Wi-Fi is not working, okay? So I just start the class, maybe it is working fine or not. If it was not, it will not working fine, maybe let's say. So then I will record the class and then simply uploaded the class, okay? Okay then, so let's continue. Very good evening, everyone. I hope everyone you are doing fine. This is the last session for the mind chapter. Okay, so if you remember in the previous class, we discussed about that the last topic was this, if you remember, that we are discussing about the reaction with HNO3, nitration part. The same thing we are going to follow. And now let's just talk about that Friedel-Crafts reaction. If you remember, the limitation of the Friedel-Crafts reaction. So if we are discussing about the Friedel-Crafts reaction, so be noted the last topic. Let me just again move where we just left. Here. So the last portion left there, this is the case that is a Friedel-Crafts reaction there. So Friedel-Crafts reaction never ever given by the aniline. Okay, this is a limitation of the Friedel-Crafts as well. So you can say Friedel-Crafts reaction, okay, not given. It means it is not given by aniline. Okay, so be noted. This is the point there, and this is all for the substitution part. Now let's discuss about the last topic, and it is going to be the important portion that is benzene diazonium chloride, diazonium salt only. Okay, so let me just quickly brief you about what is diazonium salt and all this thing. Okay, so let's discuss about the diazonium salt, the last topic, and some portion is the repeated here. So let's just discuss about that. How about the that diazonium salt? Okay, okay. So what is this diazonium salt? So the general one, that is this is it's look like this is G and there is some N2. Okay, this is a positively charged and this is some X negative there. Okay, so this is the diazonium salt simply. It can be aliphatic, it can be aromatic. Okay, so that the Z can be any group. Okay, the G can be any group. Like maybe it can be pH, maybe it can be CH3, or maybe it can be C2H5. Okay, any value can be there. Okay, next one, that if we're talking about the example part, that how about the example? So example, like this type, triple bond nitrogen have to be there. This is positively charged. This combination is present there, so it's going to be the diazonium part. And then if we're talking about, like, let me just highlight that first we discuss about this G. Okay, this is my Z and this is a G portion. And then if we discuss about this N2 part here in the very center, so this is nothing, this is like this. And if we're talking about the halogen portion here, or you can say that is anion. Okay, so anion part. Okay, so this is the anion part here. So how about the anion case, that in the anion it can be chlorine, it can be bromine. Okay, it can be NO2 as well. Maybe some will be like, ma'am, but no, we most of the time observe bromine, chlorine. No, it can be NO2 as well, and it can be HSO4 negative as well, and it can be BF4 negative as well. Okay, if you remember some naming reaction of the previous classes, maybe you know that in some cases BF4 negative also connected here. If you don't know, don't worry about this. Okay, sulfonation part. Okay, I guess we already covered that Heisenberg test, if I remember, Arul. Okay, so let me just again move that. Wait. Okay, look at this. So, okay, sulfonation part left. I will explain. Okay, just wait, Arul. So yes, this part we covered, right? And that I just told you just now that as Friedel-Crafts reaction is not given positive by the aniline because aniline is very much reactive. If you remember, this was a limitation of the Friedel-Crafts aniline class as well. How about the sulfonation? Okay. So let me just first finish this diazonium part, and at the end we will cover about the sulfonation. Okay, I forgot about that. I'm sorry. Okay. Very good evening, Ambika. Okay, so let's continue what we're discussing. That is a benzene diazonium chloride. So it's an anion part here. So this is a kind of introduction you can say. Now, that in this portion we are just going to discuss about that is how the reaction look like here. Okay,
As I already told you, it can be aryl, it can be alkyl there. But be noted, this is a kind of knot for you that aryl, sorry, alkyl, benzene, sorry, and alkyl diazonium salt is not that much stable. Okay, be noted. Alkyl diazonium salt not very much stable. If you remember in the previous class we discussed about if it is formed there, so it's quickly break. Okay, it quickly break and then there is a N2 gas release and then there's a generation of carbocation. If you remember this direction, we already covered the formation or the preparation of alcohol part there. Okay, so this is how it's look like. Be noted. Okay, this is a kind of limitation. It's not that much stable. So alkyl diazonium salt, not stable. This is the key point here. Okay. Now in the diazonium part, we are going to discuss about some important reaction like preparation. First point that how to prepare this. Okay. So let's discuss about the preparation part, how to prepare this. Preparation of BDC. Okay, if I'm using this word BDC, it means that is benzene diazonium chloride. Okay, so how to prepare this? Again, as I already told you, alkyl is not stable, so the topic of discussion is going to be the only the aryl part here. Okay, so that this is aniline NH2. Okay, and then we are having NaNO2, and then HCl we're using. Okay, and like temperature have to be maintained 273 to 278 Kelvin. Most of the time it will be 0 degree to 5 degree Celsius. If temperature little bit change, yes, it is not going to be stable. So temperature range is really much important in this case. Okay. So next that this is formed like this. This is nitrogen and this is N2 positive and Cl negative. How it is formed mechanism, this is not the part of the syllabus, so let's not waste our time. Okay, so this is benzene diazonium chloride. Okay, benzene diazonium chloride. I will change the position if it is blocking your view. Okay, so look at this. This is the simple preparation part is there. Now let's continue further. So after the preparation part, that physical property, okay, it's a kind of introduction. Physical property, like the same, that color and all these things. So if we're discussing what the physical property, so the color, color wise, it is colorless. Okay, color wise, it is colorless. It means no color. Okay, so color, colorless. Okay, second one, that state. So it's a crystalline state. It means that is a crystal of this benzene diazonium chloride. So it's a crystalline salt. Next, solubility. If we're discussing about the solubility, so it's a polar, right? So it's a soluble in water. Be noted. Soluble in water since this is a polar, okay? There is a knot again. So what is the knot? Every portion is soluble except this. Okay, if benzene, that is the X group we already covered, right? This is N2 positive and BF4 4 negative. So it's a kind of important part that every kind of diazonium salt is soluble in water except this. Okay, this is insoluble in water. I'm repeating again, it's exception, so be noted. It's insoluble. It is insoluble in water. Okay, so this is some key point about the physical property. Now let's talk about the chemical property because chemical property is going to be the important part here. Okay, so let's just talk about the chemical property. Oh, if you want to note it, just note it down. Okay, I hope you're done. So let's continue with the chemical property. Some chemical property you already know. Okay, some is the new portion for you. So how about the chemical properties? Okay, so in this case, we are going to discuss about two point that is one is the coupling reaction and one is the simple normal reaction is there. So the first one that you remember some reaction from the I guess which chapter? Haloalkane and halurine. So repeated part, this portion, this reaction involving displacement. So it's a reaction involving displacement of diazo group. Okay, so this N2 group is known as a diazo group. It means that is basically we have to remove that N2 part. Okay, wait, we will cover that portion as well. And the second one is what? Reaction involving, that is the reaction involving retention. Reaction involving retention of diazo group. Okay, so in this case, diazo group have to be maintained, and in this case, it is not going to be maintained. So let's discuss about first this portion, and again, it is a repeated part. Be noted this portion. So let's discuss more about this point, how to go with this. Now, let me just give you a kind of chart, displacement of N2 group. Okay, so I guess this point is clear that what is the meaning of that azo group maintain or not. So this is N2 group, positive and chlorine negative. So means basically we are going to break this N2 group removal. Okay, so displacement of N2 group. So this N2 group can be replaced by so many group. That is the first of all by hallucin. If we're discussing about the hallucin part, hallucin can be chlorine, hallucin can be bromine, and cyanide part also. Okay, so it is classified into the two portion. If you remember again the previous one, we will cover every point. Don't worry about this. One is the Sandmeyer reaction. So Sandmeyer reaction, I will give some brief as well. So don't worry again. And the Getterman reaction. So since we're discussing about this portion, can you just tell me the difference between this and this reaction? If you know, what is the difference between Getterman and the Sandmeyer reaction? If you know the difference. Okay, so let's discuss about this. Maybe that after that the point will be clear for you. Second one, that is by iodine. Okay, and the second be like by fluorine. Okay, so like we are discussing about the replacement, and by hydrogen H negative, or you can say by OH group, and the last one is what that is a NO2 group. So means that basically we're going to discuss about how to remove this N2 with chlorine, bromine, iodine, fluorine, hydrogen, OH, and NO2. Okay, so let's discuss about this. So like send me and get when better let's make a kind of chart, right? So that we can cover everything in a single portion. Yes. So this is our benzene, diazonium chloride. Let's just first talk about if I am using Cu2Cl2, okay, HCl. And the second part we are using that is the Cu2Br2, okay, or some HBr. And that if I'm using CH3, CH2, and OH, you can say basically alcohol, and then Cu, Cn, KCN, okay, and then if we're using Ki and heat it, and if I'm using HBF4 and again heat it, one more air, okay, then no space. Wait, let me just first adjust the thing. So in this case, what is the product? So it is replaced by the chlorine. In this case, what is the product? That it is replaced by bromine. In this case, what is the product? That is, it is replaced by fluorine. I will give you like separate reaction as well. Just wait for some time. And in this case, it is replaced by iodine. Okay, in this case, it is replaced by CN group. And in this case, it is replaced by hydrogen group. Okay, like this. And now let me just write this here that if I'm using H3PO4 and plus water. Okay, so what is happening? Again, there is a hydrogen form. It is a reason number one. Second, third. Okay, so this is a brief. Okay, these reaction we already covered in the previous classes. Okay, CO uses. No, 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 no. Well, that is the Gatorman-Koch reaction. Okay, Rul, the CO use. And there we are getting aldehyde. Okay, Gatorman is a different reaction. Gatorman-Koch is a different reaction. Now, let's discuss all the reaction one by one, right? So let's just first write about that is a Sandmeyer reaction, like how to differentiate between all the reaction, right? So let's discuss about the Sandmeyer and Gatorman all the reaction. Okay, the reaction number one, Sandmeyer reaction. And let me just differentiate with the Gatorman Koch, like how they are different. And then it's a Gatorman reaction. It's Gatorman, not Gatorman Koch, okay? So like how they're different from one another. This is the first part, this is the second part. In this case, we are using again that this is aryl N2 positive, Cl negative. Same ditto that N2 positive and Cl negative. Or let me just write X, right? General. And in this case, if I'm using Cu2X2, okay, then that is HX. For example, if I want chlorination, so I am going to use Cu2Cl2 and HCl. If I want bromination, so what we're going to use there, that is a Cu2Br2 and HBr. If I want to connect the cyanide group, so I can go with this, that you can use Cu2Cn2 and that is HCN is there. So this is how you can change the reagent, generalize. Okay. Now how it is different from this part here. So in this case, you have to use only copper, and then HX. This is a very much important key point. That between Sandmeer and this Getterman reaction, that in the Sandmeer reaction, we are using a salt of copper. Look at this. It's a salt. It's a salt of copper. Okay, this is a salt of copper. But on the other hand, in this case, this is only copper. This is key point. Okay, this is the only difference between both the reaction. Otherwise, the product will have to be same there. Okay, so like let me just write the product here. So in this case, we are getting the product. Okay, differentiate this. So in this case, what is the product there? That is final same product. This is zero. Sorry, and then X. And in this case, still that is this is benzene and this is X there. So this is the same product. Okay, this is Getterman and this is a Sandme reaction. I hope this point is now clear. Okay, Arun? That's it. Now let's see the next naming reaction. If we go with the iodination, first of all, listen my point that iodination is not that much easy. Means what I want to say that it's not like that if I am having a benzene and this is N2 and let's say this is X again. So it's not like that as the previous cases you can use Cu2I2 and just add some HI and the reaction is going to happen. No. The addition of iodine is not that much simple because you know very well iodine has a issue with the size. Okay, so just for iodine part only, we have to run the separate reaction. So what is the point? Or you can write the not as well. So what is the not? That iodine don't easily introduce to benzene ring directly. Benzene ring directly. So we are using Ki as well. It means in this reaction we can't directly use the iodine, okay, because you know very well HI and iodine has an issue with the size. Okay, that's why we are avoiding the use of HI. So in this case, what is the extra point? That the reason we are going to use the Ki, and then heat it. That's it, simple. And then we are getting iodobenzene. Okay, so like the previous two cases applicable for chlorine, bromine, and that is a CN group. Okay, for iodine, different reaction. What is the name of reaction? This is not a naming reaction. Now let's see the third part, sorry, fourth part, fluorine, fluorine connection, right? So let's discuss about the next. If we are having a fluorine, then how to go? So in this case, next is going to be the fluorine, and for the fluorine part, again it is a naming reaction. That is the name of the reaction is what? Bals, Sai, Man reaction. Okay, so this is the name of the reaction. So let's see what about the reagent again. In this case, we are using this N2 positive, X negative again. And in this case, extra reagent is what? We have to use HbF4. HbF4. Okay. And then what is going to happen? I guess you already know that is a fluorine. Is electron deficient species. If it is connected with the four part, so it's a partially that is a negative and it's a partially positive. So hydrogen has a positive charge and this bromine part is the negatively charged portion here. So then what is going to happen? You know, we discuss about that a point N2. Okay, this is positively charged. So it is forming a bond with this F negative. So this X is now connected with hydrogen. So it's become HX. HX can be leave. Okay, like this. And let me just use this chlorine here so that you can get my point. This is chlorine, and now we're getting HCl as a product. Okay, and further then if you to heat it, if you to heat it this further, and then we are getting fluorobenzene. Okay, so this is a different reaction with fluorine and iodine here. The name of the reaction is what? Ball-Simon reaction, and in this case we are using HbF4 there. Okay, two extra point. This is all for the fluorine part. Now let's see that how about the hydrogen part here. So hydrogen part as we already covered, you know. So like for this portion, let's just back again. Okay, so for a hydrogen connection, you can go with this portion and this portion. So these two are the hydrogen part here. If you're using any alcohol, so we're getting benzene. Okay, and if you're using H3HO is there, so still in this case we are getting that is the benzene. So this is how it's important. Why it's so really which important here? Because it will be important according to the conversion point of view, like how to get simply that is benzene. Okay, so which part is there? I guess no, right? So let's cover that. So next, by which group? If you want phenol, right? So it's very simple. That again, N2 positive, X negative. Be noted, if you have to use only water, plain water, I said again, that is only water if we are using. Okay, so what is happening? And this reaction occur at 283 Kelvin. Okay, it is going to convert into the alcohol. So, noting something, actually what is happening? In the preparation part, I told you about this, that the temperature have to be maintained between 0 to 5 degrees Celsius, because if the temperature is greater than 5 degrees Celsius, this BDC is not stable. Okay, it quickly form the alcohol. Okay, so like in this case we are using a warm water, just be like heating with the water, just the steam of the water, and it is increasing the temperature, and we are end up with the phenol. Okay, so this is the point here, and HCl and plus N2 gas release. Okay, so this is how we are end up with the phenol by OH group. And let's see the last part, that is by NO2 group, right? So okay, that how to go with NO2. Again, again, that is the same, N2 positive, X negative. In this case, we have to use basically NaNO3, and then it's simple, and then we're getting this. Okay, so this is all for the reaction with the benzene diazonium chloride by the replacement or by the displacement of N2 group. Okay, if you want to note it, let me just so one by one. This is the first one, Sandwich and Kettenman reaction. First, this is the second with iodine, or let me just write bioiodine. And the next, that is the bifluorine. Okay, and this by which group? And the last one is this, that is by NO2 group. This is all for the reaction with benzene diazonium chloride by the replacement of N2 group. Okay, so I hope this point is clear for you. Franklin reaction. No, Franklin reaction is a different point. Okay, this is not the part of this. In the Franklin reaction, you are using NaI, and it means that reaction is famous for that for the formation of iodine. Let me just quickly give you a brief. So there you have to use any Rx, and then we are using NaI in the acetone. Okay, heat it, and then we're getting RAI. Okay, and then some NX remedies. What is this X? X can be chlorine, X can be bromine, okay? X can be fluorine. This is the Franklin reaction, Ambika. Okay, please be noted. It's not the part of this BDC. Okay, Ambika? Okay, I hope it's done. So let's continue, okay? Because we have to finish so much content. So that's it. Now let's talk about the next one. That is, if you have to remove, like we are not removing the N2 group. Okay, so the last one, that is a coupling reaction. So let me just cover that portion now. Okay, and in this case, you have to add copper and heat as well. Okay, that's it. Now let's see the next part. That is reaction involving retention. Reaction involving retention of N2 group. It means it is not going to leave. Okay, and it's actually famous for the name, that is coupling reaction. Coupling reaction. Okay, so in this case, there is a two reaction, common reaction, normal. Okay, so first of all, the same N2 positive, X negative we have to use, and let's say phenol. Okay, phenol. Reagent is very much important, because if you to change the reagent or the pH condition if changed there, obviously we are end up with a different product. Okay, so pH maintenance and that basicity acidity is really important here. So if in this case I am using phenol, okay, phenol, and we are using basic condition, or let me just write in the presence of OH negative ion. So what we are getting? Okay, first of all, my question to you: do you know this coupling reaction is a redox reaction? So according to you, which one is electrophile and which one is a nucleophile here? Yes, azodine. Yes, please. Do you know which one is being like electrophile and which one is being like a nucleophile here? Yes, please, anyone, Yes, very good. Nucleophile is the phenol, and this is the electrophile there. It's like a common sense kind of thing. This is a positively charged. Okay, all the mechanism is not important, but still that this nitrogen is going to attack here. Okay, and as you already know, this is a ortho or like para directing group. So the group may be connected at para or ortho, but major one, there's a two ring is going to combine. So para is the major one. We have to cover only the para. So this is electrophile, and this is a nucleophile. Okay, somehow it will be asked. So be noted, electrophile and nucleophile. So let's see that how the reaction is going on. Just for coupling purpose, I'm going to show it's be like that way. Okay. So this nitrogen is not going to remove, and then OH. Okay. So OH still maintain, OH is not going to leave. What is the name for this compound? So the naming is again not difficult. It's very simple that you can say with respect to this, it's a ortho, it's a meta, it's a para position. So the name become para position hydroxy group. It means OH group. So para hydroxy azobenzene. Why the name is what? Azo for NN part and the benzene for this portion here. So this become para hydroxo azobenzene. As is this complete coupling, okay? This group. Okay, wait. I have to use the next slide. Listen. What is the meaning of azo? That if this is benzene, okay, and this is connected in this part. So this is azo group, right? So again, I'm explaining the naming. Listen my point. OH for this para hydroxy, okay, and this for this portion, okay, we're using azo, and for this portion, we are using benzene. So that's why the name become para azo benzene. Okay, this is the meaning. One first reaction. And the same, if in place of OH, we can use another thing as well. Same BDC. And if we are this time, we're using aniline. That's it. That the pH is important here. Okay. In the phenol, we're using basic pH, and in case of aniline, we have to use the acidic pH, like term and condition apply, acidic pH. So again, what is the product? Let me reduce the arrow. H positive. So again, okay, it will remain maintained. So like the previous one, name, I guess name part is now clear for you, like how to go with the name. So it's become para, okay, like para amino group. So it's become para amino, and then again azo, okay, and then benzene. So it's become that azo be like coupling. It's a coupling here, benzene. And how about the side product? H2 plus HCl. Let me just check in the previous one. I miss, I guess. Yes, of course, the product is what? Water and plus Cl negative. Okay, this is the side product, and this is the side product. With aniline, acidic condition, with OH group, basic condition. This is the only thing we have to remember. Okay, this is all for the coupling portion. Done. Now, question be like that what is the use of this coupling reaction? That what is the use of the azo compound? So hydrogen on phenol is electrophile. Sorry, Niharika. No, it's still nucleophile. Phenol, I guess you're asking about the previous one, right? I missed this one. Okay, no, 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 no. That first of all, this portion is not going to like participate. Listen, actually, what is happening? That let me explain the mechanism here. This is R. Okay, try to understand. This is pH and this is triple bond. Okay, one nitrogen has a positive charge. Okay, and then this OH is not participating. This OH increase the density here. This ring open up, attack here. Okay, and this is how the bond open up. So basically, it is a benzene combined with nitrogen, the terminal one, right? This R is already connected here, right? Now there is a positive charge. Okay, and it's delocalized. And then this is how the reaction going on. Okay, Niharika, are you getting now? That is not hydrogen. The complete benzene ring is electron rich, electron revolving. Okay, because benzene can be like sometime electrophile as well, nucleophile as well. I hope this point clear now, Niharika. Still any problem? Let me know. Okay, this is all for the coupling, and we are discussing about the uses part, right? Like why, what application portion you can say. So let's continue about importance in synthesis. Importance in synthesis of aromatic compound. Like why we are using, why we can't directly form iodobenzene, chlorobenzene, fluorobenzene. What is the actual use of this BDC? Okay, so the point number one, the use number one, you can say that very good intermediate compound. But is the plus point if you remember that if you directly go with the chlorination, bromination on a benzene, okay, so there's a positive charge on it, aromaticity break. But in this case, the problem sorted, just quickly remove that. Okay, there's a no charge appear on a benzene, so this is a better point. And the second point that is you can use to introduce any group. Like you can use fluorine, you can use chlorine, even you can use bromine, even you can use iodine, you can use cyanide, you can use OH group, and you can use H and many more group. Okay, any group you want to insert, just go for that. Okay, so that's it. This is a plus point about the intermediate. Okay, and I guess this is all for the diazonium chloride part or BDC part here. Okay, now let me just cover the sulfonation and then we are going to cover two important question. Okay. So wait for the sulfonation. I missed the sulfonation part here. Last topic, sulfonation. Okay. So how about the sulfonation of the aniline? That in this case, this is aniline NH2, and we have to use the again that is the concentrated H2SO4. Okay. What is happening? This is NH. Okay. So as I already told you in the previous class as well, H2SO4 is a behaving like acid first. So it is going to attack first on aniline. Okay, so be like this is N3. Okay, it take this is positive. Okay, remember the exception, the nitration process. And then in order to stabilize this H is so for negative part connected here. Okay, so this is intermediate here, extra intermediate. And if I'm talking about the name, this is known as aniline, anilinium, anilinium hydrogen sulfide, sulfate. Okay, and then further, if you to heat it from this to this temperature, okay, then we are getting this NH2 and SO3H. Okay, this is sulfonation. In this case, what is the extra point? The previous electrophilic reaction, this was not there, right? But in this case, this is extra point intermediate where end up. Okay, this is extra point in a sulfonation, or Like the new name for this, we are going to use zwitterion. Okay, so now let's introduce this word, that is zwitterion. In the next chapter in biochemistry, we're going to discuss again about this zwitterion. So what is the meaning of this zwitterion? That, let me just write, this is NH2, right? This is NH2 and this is SO3H. Now they just changed the position. Okay, this aniline has a lone pair and abstract the hydrogen from here. Okay, it's an equilibrium reaction. And then what is happening? This is positively charged, and since the hydrogen is abstracted from the SO3 part, so it's negatively charged. So what is the meaning of this word zwitterion? In short, neutral. Okay, that a species in which the total charge is zero, but still there is some charge. If you're observing, equal positive and negative charge. I'm sorry, equal positive, equal negative charge. So this thing is known as a zwitterion. Okay, this given thing. Positive, negative is known as a zwitterion. And in this case, ma'am, how it is moving, how about the reaction, how about the mechanism? Mechanism is not important again. Okay. Otherwise, like in this case, this SO3 is going to shuffle and everything is there. Okay. But again, mechanism is not important, so leave that mechanism part. This is all for the sulfonation. Okay, Rule. Now you are done. Any problem with the theory, please first let me know, because now let's solve some questions only. Okay. So the theory part is covered. Let me just take some question now. This is question, and actually this question is from the main portion. It look maybe lengthy or like maybe you're not able to understand, but still, okay, it's not like it's difficult. Just answer the question, okay? So the same major product you have to identify, okay? I'm repeating again, major product for this given thing you have to identify. So in this case, I'm using NaNO2, okay, or aqueous HCl, and then temperature is 0 to 5 degrees Celsius. Okay, so major product you have to identify. Options are, take your time and then let me know the answer. Okay, even you can start, till then I have to read the options. Option number A, answer is actually unexpected in this case. So again, take your time, analyze the thing, and then you are end up with the final answer. Okay, first of all, like how to approach the question if this reagent is there, okay, or HCl and NO3 plus Cl is there, and you're observing somehow aniline. So the main motto, the main agenda, go with the benzene diazoxide chloride kind of formation. Okay, it is a kind of hint for you. Some will be like, ma'am, then what is left? Okay, no, answer is not that much simple. Otherwise, if you already solved this question, then it is easy. Otherwise, if you are a new, then maybe not able to solve. Let time start now. Okay, Arul. Okay, Arul. If let's suppose I have to apply the common sense, So in this case, count the number of carbon. It's a six member, right? You said B. Six member. Okay, six member. Five member. Okay, five member. And then noting something like what you are not observing here. This is my first one carbon is there. Isn't it in this case the carbon is not present there? If I recall in the BDC, not at a single point we covered that the carbon is less. Okay? Okay, Ambika. So lock. Okay, then it is not going to change, right? So you can solve this question just by common sense. Okay, if I don't know anything, maybe some people like, ma'am, isn't it an NO3? Okay, it was NO2. If let's suppose after this complete reason, one more time NaNO2 and copper part is mentioned, then you can go with the option number C. Okay, so C is again, and come on, the number of carbon again, 6, and look at this one extra carbon. Total carbon have to be maintained, that is 12. And in this case, if you're counting like 6 plus 6 become, that is a 13 carbon. In this case, it's become 11 carbon. In this case, again, it's become 11 carbon. If I have to go with the common sense, definitely I have to mark the option number D is the correct here. Right? This is how you have to approach the question, organic chemistry question in the paper. Okay, but let's see how actually it is happening chemically, right? So let's see, that is option D is the correct, but why option D is the correct, this is my question, right? So let's find out the complete process that how to go with this. So option D is the correct, very good, Rulin and that Shiva and one more, Ambika, right? So you're right now. So but how? So let's go. It's a six member ring. Okay, anyone, can you just tell me the given aniline is aliphatic or aromatic? Yes, please. This given aniline is aliphatic or aromatic. Do you know the difference between aliphatic aromatic? Yes, please. No. My question is not. My question is aliphatic or aromatic, Shiva. Okay, I'm not asking about alicyclic, acyclic. It's aliphatic. Okay, and I can prove this as well. Why this is aliphatic, Shiva? Okay, because see this, look at this. That this portion is the ring portion. If it is, let's suppose, connected here, then you can go with the alicyclic portion. Okay, but in this case, observe this. It is a part of the side chain. Look at this carbon and then. So this portion is actually the chain only and aliphatic. Okay, so this is aliphatic part. So it means one point is very much clear, that in this case the given benzene diazonium halide is not going to be stable. Okay, or I said benzene, I'm sorry, that is allyl diazonium chloride or any halide can be there, right? So let's go simple. What was the reagent? So reagent is NaNO2 and HCl, I guess, right? Aqueous NaCl. And 0 to 5 degrees Celsius temperature, okay, we are able to maintain, but no point because it's not going to be stable. So then, okay, I have to write it here. It's a six member ring and it's a five member. Okay, just give me 1 second. I will come. Just wait, okay? Okay, I'm sorry. It's working fine now. Okay. So yes, I'm really very sorry about this. So let's continue. Okay, so what is happening now? That this carbon, okay, you have to make sure that sometime if you are having an issue, you know what is the problem with the student? They'll be like nitrogen, okay, and done. No, it's not correct because we are missing a one carbon here. So then how to go that you can use carbon if you are having a problem with the number. Otherwise, this is how it's look like. Okay, positive and chlorine. This is the thing first of all we're getting. And again, it is not stable. This is very much unstable because it's a aliphatic here. Then what is going to happen? The nitrogen like we are going to leave. Chlorine is just a counter ion. So N2 gas remove released here. Okay. So we are getting it is a six member ring, and then it's a five member ring and it is a positively charged. And which kind of positive charge it is? Primary carbocation. And everyone, primary carbocation is not stable. It's not stable there. Then what we can do there? Go with the rearrangement. Ring expansion have to be there because it's a five-member ring and positive charge is not so much stable. Okay, so the next step is going to be the ring expansion. So let's go with the ring expansion. I hope you already know we covered this thing so many times, ring compression, ring expansion. So just simply this bond break like this. Okay, just imagine the thing. It is negatively charged, it is positively charged, and it's connected. I'm repeating one more time. Listen. Okay, so what would be the positive charge? You can go this side, you can go this side. This is totally your choice. If it is symmetric. If let's suppose it is not symmetric, if it is be like this, then you have to go with the more substituted one. If it is not substituted, you can go with any side. Again, listen. This is how the bond break. Like this is positive, so you can just count that is a 1 and 2 carbon with respect to the positive charge. Okay, if let's suppose you are having a problem with the number, so go with alpha and beta. Okay, so it's alpha position, it is beta position. It's totally your choice. Okay, so it's negatively charged, it's positively charged, and how it's look like. Okay, this is how they are forming a bond. Again, if you are having a problem with anything, just go with the numbering. Let me just give the number: 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. Okay, so let's see the next product. It is a six-member ring. Okay, next is also a six-member ring. Okay, let's continue with the numbering. This is 4. Match, match. It's a 5. It's a 6. It's a 3. It's a 2. It's a 1. Okay, I guess it's fit now, right? And see this in the ring where the positive charge at second carbon. Second. Okay, this is my second carbon. So let me just search. The positive charge have to be there. Okay, so then next we're using aqueous. You know what was the meaning of that aqueous HCl? That is directly and indirectly water. Okay, so if we're using aqueous HCl or diluted water, next thing OH is going to be added, right? So means that in this case that OH is added here. Okay, so let's just back again. Some will be like, ma'am, no, your OH is like bottom. Okay, it's totally your choice. Okay, it's a symmetric molecule. If you to go with the option numbering, same. If you to count like 1 and 2 carbon, okay, or like in this case, you can simply count it from here like 1 and 2 carbon. So it is the same thing. If you want to match with the option, so just go for that. Okay, I can write the same thing like that way as well. Okay, it is same, totally same. So hence option D is the correct answer here. I hope solution is clear for you. Still, if you are having any problem with the solution, let me know. Okay, if you want to note it, the ring expansion, all this thing, look at this. Okay, this was the question. Easy, sorted. Let me just check one more last question. Okay, then we are going to end this. Okay, this is good one. Answer this question again. It's a main question. Okay, question: aniline dissolve in diluted HCl, okay, is reacted with sodium nitrate at 0 degrees Celsius. Next statement: this solution was added further dropwise to a solution containing equimolar mixture of aniline and phenol. Okay, aniline and phenol in diluted cell. Okay, so you have to identify the structure of the final product. Okay, structure of major product. Let me tell you what is the statement. Give us the idea. We are just starting with aniline. Okay, add some diluted HCl within the presence of sodium nitrate 0 degrees Celsius. It means this first statement simply identifies that we are getting BDC. Okay, this is the first point. And now, question further proceed that after once the BDC formed, in this case, you are adding a dropwise equimolar ratio of aniline and phenol. Two things we are adding in the diluted HCl. So question be like that what is the final product here? Okay, options are now you can continue. Okay, try to answer the question. Till then, I have to give you the options. So, options are in option B. Okay, I have to read the option C here because no space. Okay, in option D, none of these. Okay, yes, please. I will rule. Okay, wait, wait. No, no, both can be there. Okay, maybe you're asking about the option, so it is not very clear. It is NH2. So question simply want to ask that is a coupling with NH2, coupling with OH, or coupling with between N and N means like benzene diazonium chloride only. So this mean like both benzene diazonium chloride combined. In this case, one benzene, one aniline, one benzene, or like one phenol part here. Okay, I already told you pH, basicity, acidity. I highlight this point there. Equilibrium mean like 50-50. Both are same so that you can't change your answer be like according to the concentration point of view. For example, if let's suppose I said 80% aniline, you'll be like, ma'am, 80% is the measure, right? So 50-50. Equivalent molar means same, right? According to that logic, what will be the final answer? So in this case, the only thing you have to identify and then you are able to solve the question. Okay, that one key point hidden in this question. Okay, okay, okay. Okay, Arul. Okay, I guess the problem between option A and option B, right? Now let me just back again to our the reaction. There is only two reaction. I told you that was important part. So see this. Nothing striking something in your mind. If you are using base, OH is going to combine. If you are using acid, so NH part is going to combine. Okay, we discussed this pH and sometime what is it written here like pH is greater than 10, so okay, basicity. Okay, and sometimes written pH is less than 5. Okay, it's an acidic condition, so you have to search these things in the question, hidden key point. Okay, so let's just back again and now read this. I know one thing after reading this question that then the BDC formation complete. Now equimolar and see indilute HCl. This HCl word differentiate the options here, and only one option that fulfill in the acidic condition is only the option number A. Okay, not an issue when we are about to end the class. Okay, then you can watch the recordings. Okay, so is this point clear that what is the correct answer? Option A is the correct answer here. Okay, so option A is the correct. Anyway, let me explain what is the question really want to ask here. So first of all, that you have to start with normally aniline. Okay, and according to the question, we are using NaNO2 and plus HCl there. And then there is a formation of N2 positive and Cl negative. Okay, this is the point number one. And now we are giving a choice like in the option in the first case, we are using phenol. Okay, in the second case, we are using aniline and 50-50. Like let's suppose if it is 5 molar, so this is also 5 molar. It means equal concentration, but the term and condition apply that we have to use acid. Okay, that add them and add acid as well. So acid be like HCl. So if we are using acid, so automatically the benzene diazoxide chloride pick up this because it is a favorable product in acidic condition. Okay, so that's why the final answer of the question be like that both are present and both can be reacted with this. But question is what major product, you know? So major product means that only the major product in acidic condition is possible with aniline. So the final answer for this question is going to be the aniline there. Okay, so hence option is the correct answer here. This is how we are approaching. Okay, easy topic, not very difficult topic. You can say the one of the easy topic in the amine chapter. Okay, so that's it. This is all for the chapter, and this is all for the amine part. Okay, we are just left only one chapter, that is the last biochemistry. Okay, so easy one. Now Arul asking about the basicity order, right? So listen my point, Arul, that if you're having gaseous phase, okay, so in a gaseous phase, you know that one molecule here, second here, third here, four here. So like there's a no connection between the molecule. You know, generally ideal gas, no interaction between the particle. Remember that a KTZ theory, okay? No, it's not matter, okay? Ambika. Yes, sometimes pH range can be changed, but it's not the part of the syllabus. Simply remember acid. It can be dilute, it can be concentrated. Okay? So simple search for acid or a basic condition. Okay, so what we're discussing, yes. So gaseous state. So gaseous state be like intermolecular force of attraction is not the issue. It means hydrogen bonding exists. It is not the issue. No, it's not an issue. So now, since we are discussing about basicity, everyone, right? So how about the basicity? That basicity is directly proportional to the electron donating concept because what is base? A donor, right? So let's just talk about if I am talking about tertiary amine, okay, tertiary amine, secondary amine, primary amine, and then you can say ammonia. Okay, so in this case, like our normal limal topic, like concept, that three electron donating group. In this case, only two electron donating group. In this case, only one electron donating group. So donor more basic. So what is the correct order? Tertiary is more basic over the secondary, is more basic over the primary, is more basic over the ammonia. So this is a basicity order for the gaseous state. The point number one. Okay, not an issue. Normally go with the electron donating character here. But what if we are having aqueous state? Okay, if we are having aqueous state, so let's just talk about the point that is aqueous state. So if we are discussing about the basicity in aqueous state, there is a two factor more added. The factor number one, steric factor. Okay, what is the meaning of this word steric factor? Steric factor, think about it. Liquid means closed particle, so much hindrance, they start pulling, okay, pushing one another. So interaction automatically weak. Yes, interaction is not that much good here. So how about the steric factor? So according to steric hindrance, I can say my tertiary amine is more hindered because let me just write that as a CH3. Okay, this is my CH3 and this is the hydrogen there. So 2CH3 is so much hindrance, so logical. Now the steric number factor, steric factor tertiary, then secondary, and then primary. Okay, according to steric factor, this is the order. Okay, second factor, that the same electron donating concept. Okay, it will remain same. Tertiary, secondary, and primary. The same ditto like the gas state. The last factor is the hydrogen bonding. Okay, so how about the hydrogen bonding? Uh, Recall again that in ammonia, if you have to consider ammonia, so in case of ammonia, there is a total three hydrogen bond. Okay, next, if we're talking about secondary, let's say only one hydrogen bond. So if you have to go with the hydrogen bonding, number of hydrogen matter. So I can say that you have to add ammonia as well. How about the case? For the hydrogen bonding, ammonia is a winner, then primary, then secondary, and then tertiary. Okay, so there's a you can say total three factor. Two factors add that tertiary, secondary, and primary is the order. One factor said that is the primary, secondary, and tertiary is the order. Whenever in the science two theories clashing, okay, so then we have to combine them, and at the end the cumulative effect is the resultant. Cumulative be like 50-50. Okay, some portions said that steric, some said hydrogen bonding, so let's combine them. Now if I am using this R, if I am using this R as a CH3, listen, okay? If we are using this R as a CH3, so what is the order of the basicity? That not the tertiary, not the primary. Here, look at this. Tertiary be like, I'm the winner. Primary be like, no, I am the winner. Okay, and then you can say secondary come into the picture. Secondary be like, okay, you can fight and I win the race. So what is the correct order? That is a secondary, followed by primary, followed by tertiary, and then ammonia. This is the basicity order. Be noted. Okay. If R become CH3 CH2, or you can say ethyl group. So see the changing in the order. It is secondary, followed by tertiary, and then primary, and then ammonia. Okay. Now, if my R become CH3, CH3, and CH2, as the size start increasing, so tertiary be like again I'm the winner. So something strike in your mind, that is size is small, secondary, primary, and tertiary. And now see the shuffling, tertiary and tertiary second in this. And after the three carbon, you can use any number of carbon. The order will remain maintained. Okay, so again I'm repeating, for the CH3 the secondary is the winner. As soon as the size of the chain increasing, so tertiary start dominating. So if you are using ethyl, second position, if you're using propyl, first position, and up to so on. Okay, Arul, this is all for the order. Now your turn. Any problem, please let me know. Okay, it's enough. Arul, is it clear now? Okay then. So I hope it's done now. Okay, now it's your turn. Any problems still left? Let me know. Otherwise, let's end the class then. Okay. Okay then. So thank you so much everyone for joining the class. Next chapter will be biochemistry topic. Okay. Thank you so much everyone for joining the class. Have a nice day. Bye bye all. Thank you so much.